Question 1 follows directly from our lesson on geometric sequences. This question reads as follows. It says that suppose that 1 over 2, 1, 2, and so on is a geometric sequence. So they're saying this sequence here is a geometric sequence. We are told here that we are given a geometric sequence defined by 1 over 2, 1, and a 2, and we can see that this is an infinite sequence because it continues, it doesn't stop at 2. Because it's a geometric sequence, we expect that the common ratio between successive terms to be the same. In other words, when I say here that 1 divided by 1 over 2, I can see that I'm going to get a 2 here. Because remember, to solve this, you're actually going to have 1 divided by 1 over 2 will be equals to 1 multiplied by 2 over 1. And obviously, when you multiply this, it will give you a 2. So we can see that the division between the 2 gives me a 2. If I say here the 2, which is the third term, divided by the second term, I'm going to have a 2 divided by 1, which simply is going to be a 2 because any number divided by 1 is that number. Then we have a 2 there. Therefore, I have confirmed that this sequence is indeed a geometric sequence as I'm told. Now I can go do the questions. Question 1.1 says to me that calculate the 15th and the 23rd term. And it's given for 4 marks. Now, obviously, we can see that the 15th and the 23rd terms are terms somewhere there at the far point in this sequence. They are at the far point in this sequence there. So for us to answer this question in a simple manner, we know that any term in this sequence will always have a pattern or be defined such that we're going to have an A multiplied by an R. But at the R here, we're going to have the exponent on the R is going to be 1 less the number of terms. In other words, we're going to say 15 minus 1 so that we have a 14 here. This is the pattern that we know and have observed when we studied geometric sequences. Now, at this stage, this question becomes very, very, very boring because we know that term 1 here is given by A, and in this case is given by 1 over 2. So our term 1 here, we said is A and is given by 1 over 2. That means I can substitute the 1 over 2 here. I'm going to put a dot because, dot means multiplication. And we just said now that our common ratio, the R here, is actually given by a 2 because when we divide the successive terms, we get a 2 here. Now, this is to say here, I'm going to substitute the 2 here and say is equals to a 14. Now, to solve this, I can simply use a calculator. When I pull my calculator, I'll just punch these numbers to say 1 over 2 multiplied by 2 to the power 14. And this then says that our term 15, therefore term 15 is going to be equal to 8,192. We can do the same math to find the 23rd term because we know that it's going to be defined by A, the first term, multiplied by R to the power 22. Because we say here that the exponent should be 1 less the number of terms. In other words, we subtract a 1 on 23. Now, this will then become a simple substitution problem because I'm just simply going to substitute the 2 here and multiply it by 2 to the power 22 as well. Because remember, my R here, the common ratio is a 2, and the first term A is 1 over 2. And again, this then becomes a very, 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 very boring question because you can simply just punch your calculator to then find the answer. And this then says to us that the 23rd term is actually defined as 2,097,152. And of course, this answer should make sense to you because we said that the geometric sequence is actually an exponential sequence. That means it grows at an exponential rate. It makes sense by the time we get to term 23, we would have a very large term because, these terms are growing at an exponential rate. If you continue multiplying them by 2, they're growing faster and faster. Now, this question, you said it is 4 marks. What they mark here actually is the substitution. They give you 1 mark for the substitution in each of them and give you 1 mark for the final answer. And that's where you get the 4 marks. 1.2 says determine the general term of the sequence, and that is just 1 mark. Now here we're looking at 1.2. We want to find the general term. Now obviously to find the general term, I'm going to use the general formula ARn minus 1. And again, I just substitute the A here and I also substitute the R, which is given by 2, and we're saying here we're going to have n minus 1. Remember, when we're looking for a general formula, we don't substitute n here because we're trying to find a formula that can help us to find any term in the sequence. Now, to simplify this, what I will do is that I will keep the base because I can see that I'm dividing by the same basis here. I'll keep the base 2, but because they're dividing each other, you must remember here that this is the same as 2 to the power n minus 1 over 2 because this multiplied by 1 will give me this, right? And I still have the 2 at the bottom. So that's what I'm saying here. I keep the base because it is the same, and now I subtract the exponents. I'm going to have n minus 1, and I'm going to have minus 1 as well because the 2 here, it has an invisible minus 1. So I'm having this n minus 1, then I'm subtracting minus 1 because we are dividing. Our rule says when we divide, we subtract. Remember your laws of exponents. And simplifying this will then say, therefore, Tn is equals to 2n to the power minus 2. Another way in which you can solve this, there are many ways. I think that's the sweet thing with it. I'm going to start from this point here, where we have 1 over 2 to the power n minus 1. This can be rewritten as 2 to the power negative 1. I can rewrite 1 over 2 as 2 to the power negative 1. Remember one of our rules of exponents to say if you have a 1 over 2, 1 over a is the same as a to the power negative 1. I'm using that rule, right? If you have 1 over a is the same as a to the power negative 1, I'm using that rule here. Now from here, I'll then have this 2 to the power n minus 1. And here I can then use my rule, the other rule of exponents that says you keep the base because I have the same basis, but I add the exponents in this case. So I'm going to have the n minus 1, and here we are going to have a plus minus 1, which basically will give me negative 1. So here I'm going to have a negative 1. And like at the top there, already you can see I'm still going to have 2 to the power n minus 2. Whatever route you take, it will give you the same answer. Now this, they just only mark the final answer because, really it's easy to do these things. You've been doing these laws of exponents from grade 10. 1.3 says which term of the sequence is equal to 16. In other words, Tn is equals to 16. Which term, right, is equals to 16? So what is the number of terms? In other words, we're looking for the number of terms. Now to solve this, I'm simply going to say, okay, my nth term, I know from the previous question that my nth term, Tn, right, Tn here is given by 2 to the power n minus 1. That is to say here, I'm going to have 2 n to the power minus 1 is equals to a 16, right? Because remember, Tn is given by this now, and I can simply now solve for the n. Now, to solve for n, it's important to notice that the 16 can be rewritten as 2 to the power 4. And from here, this question becomes very, 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 very boring, because we all know that if I have two powers that I am saying that they're equal to each other, it then means for those powers to be the same, the bases and the exponents must be the same. And in this question, we can see that the bases already are the same. We have a 2 here and a 2 here. So it means if these exponents are the same, then these two powers will then be equal to each other. So this is to say that if we say that, if this would imply that n minus 2 is actually equals to 4, right? Because if these two are the same, it means here I'm going to have the same number. Well, let's say a number 4, we expect this to be a 4, and here also have a 4, then these two powers are the same because they'll all be 2 to the power 4, 2 to the power 4. So these two must be the same. Now this would then mean when I simplify this, n will therefore be equal to a 4 plus a 2, because remember we are having a 4 this side, and I'm taking these 2 to this side, so it is going to be a plus 2, so that I have a 6, because 4 plus 2 will give me a 6. So my final answer should be a 6. And this answer makes sense because remember that the number of terms is an element of natural numbers. It can only be counting numbers. We expect a number that is like that. So it means when we get to the 6th term, our term would be 16. This question is marked out of 3 marks. So obviously here, they are going to mark the fact that you actually equated this term to the general term, and 1 mark will come from simplification, meaning using your laws of exponents and simplifying that, and the final answer would also guarantee 1 mark if it is correct.